Hi everyone, this is Engineer Rafi and welcome to our review online. This is a continuation of our previous discussion related to centroid of areas of plane figures. Okay, and now we will discuss about centroid of areas bounded by curves. Okay, it's the same thing that we will use the analysis for a vertical and horizontal strip. Supposing we have a function and the other one, and we will find the centroid bounded by these curves. Okay. And first thing to do is to calculate the area. Okay, first thing to do is to calculate the area. The second one is to calculate the intersection, because we will be needing this in for our limits. And the next one is to calculate the centroid. Okay, so assuming we will use for a vertical strip, okay, the centroid for this will be our bar y. Okay, this is our x-axis and this is our y-axis, and this will be our bar x. This bar x, that is the location of the centroid from the y-axis. This bar y, that is the location of the centroid from x-axis. Okay, so our formula here is that area total times bar x, that is equal to integral of x dA, differential area. The limit, okay, this is y dx. Okay, y dx. So our limit will be in terms of x, x1, x2. Where is x1, x2? This is the point of intersection, x1, y1, and the other two is x2, y2. These are the point of intersection of the curve. Okay. The next one is area total bar y, that is equal to integral of y over 2 dA. Still x1 and x2. What is this dA? dA, that is when you calculate the area bounded by these curves, we have integral of y dx, if you remember from our previous video, y dx. Okay, if this is dx, your limit to use is in terms of x. Okay, x1, x2, and this y, that is equal to y1 minus y2 dx. Okay, the value of y of the first function or the first curve minus the y of the second curve. Okay, this is your dA to be substituted here. Okay, now there's something to remember related to y over 2. This y over 2, that will be equal to y of the first curve minus y of the first curve squared minus y of the second squared, y of the second curve squared divided by 2 dx minus. Okay, so this will be our formula, x dA, and then y1 squared minus y2 squared over 2. Okay, when we are using a horizontal strip, because not all the time we can use both, either horizontal or vertical. Sometimes it is only applicable to use a horizontal, and sometimes it is only applicable to use a vertical strip, depending on the condition. Okay, like for example, okay, we have the curve here, and bounded by the area, by the line. Okay, and we will find the centroid of this. Okay, we cannot use horizontal, we always use vertical. This is y dx. Why? If you move this vertical strip along the curve, along the area, okay, it will always touch the curve and one of the conditions. This is the x-axis. If at this point, if you use horizontal on this point, okay, if you move up and down, this will not touch the curve at this point. Okay, so that's why we have vertical and horizontal analysis. Okay, when using horizontal, okay, this will be our y, bar y, and this is our x, bar x. This is x dy, okay, x dy. And here your x will be equal to x over 2. Same here, y over 2. Okay, this is y over 2. Now your area, your centroid here will be area total bar x, that is equal to integral of x over 2 dA. Your limit dA, if this is dy, y1, y2. Okay, because your dA, that is integral of x dy. If this is dy, this is y1, y2. If this is x, that is x of the first curve minus x of the second curve dx, dy. Okay, because this will be in terms of y, right? This will be in terms of y, so dy. Okay, so the bar y can be computed as area total bar y integral of y1, y2, y dA. Here, same like y over 2, this one can be replaced as integral of y1, y2 and x1 squared minus x2 squared all over 2 dx. Okay, area total bar x. Okay, so this is our formula for bar x, and this is our formula for bar y. Okay, let's have an example. Can you interchange these two, x2 and x1? Yes, you can interchange. The only problem will be you will be getting a negative answer. Anyhow, we will ignore that negative. Okay, we can interchange also this one. It's either y2 minus y1. That's okay. We have an example here. Find the centroid of the area bounded by the curve x squared equals y and y squared equals 4x. So the first thing to do is to identify the curve and then graph the curve, compute the point of intersection. The first curve is a parabola that opens upward. Okay, please check our previous video in analytic geometry. The second curve is a parabola that opens to the right and the center is at 0, 0. So the intersection point and the condition is bounded by the two curves. So this is the area. In this case, we can use a horizontal or vertical strip, because if you move this, it will always touch the two curves. If you use horizontal and if you move up and down, then it will always touch the curve at the same time. Okay, so assuming we will use a vertical strip to find the centroid. Okay, this will be our bar y, and this is our bar x. This is y dx. Okay, y dx. Okay, so the second one is to calculate the point of intersection, because for the limit, the first intersection is 0, 0. Okay, the second intersection is the x squared is equal to 4y and the y squared is equal to 4x. Okay, take the value of x here and then substitute to the first equation. This is y squared over 4. So take the value of x, it will become y squared over 4, and that is equal to 4y. Then solve for the value of y. Sorry, there is still squared here. Okay, because there is a squared. Now if you solve for the value of y, we already solved from our previous video, this y that is equal to 4 and x equals 4. Okay, that is the point of intersection. When you solve for the value of y and you substitute the first or second equation to compute for the value of x. Okay, so this is 4 and 4. Now, next thing to do is to calculate the area of this region. So the area, that is equal to integral of y dx. Okay, this is, take the value of y, this will be y equals x squared over 4, and this will be y equals square root of 4x. Okay, so your limit here is in terms of x 0 to 4, and your y, that will be equal to y of the first, okay, y of this, square root of 4x minus y of the second curve, x squared over 4 dx. Now using calculator, we can solve for the value. Integral, close open parenthesis, square root of 4 alpha x minus fraction alpha x squared over 4, limit from 0 to 4 equals. So our area here is, okay, this is the total area. So while waiting for the answer, you can double check your solution. Okay, so when we have the area, we can now solve for the value of the centroids. Your centroid area total in our formula, that is area total bar x, that is equal to integral of x dA. Our dA is this. Okay, our dA is this one. Okay, our answer is 5.33 xdA. Okay, and dA is from 0 to 4. So your x is x times the value of dA, square root of 4x minus x squared over 4 dx, integral from 0 to 4. Okay, your area total is 5.33 bar x. So bar x can be computed now. Integral of, okay, close open parenthesis alpha x, close parenthesis, close open parenthesis, square root of 4 alpha x minus fraction alpha x squared over 4, okay, and then limit 0 to 4. So this is 5.33, and let's check what is the answer. 9.6. Okay, 9.6. So bar x, that is equal to 9.6 divided by 5.33. 9.6 divided by 5.33, that is 1.8. Okay. 1.8. So this is the value of bar x. To compute for the value of y, okay, but from the choices, okay, practically from the choices, our answer is letter A. Okay, because bar x is already 1.8. But sometimes, maybe the choices, if this is 1.8, we will solve for the value of y, either 1.8 also or 1.6. Okay, solving for the value of bar y, okay, area total bar y, that is equal to integral of y over 2. Okay, this is y over 2. Y over 2 dx. Okay, x1, x2. What is the value of our y? That is y of the first minus y of the second over 2. Y of the first one, this is dA. Okay, but we can simplify this formula by y of the first one squared minus y of the second one of the curve squared all over 2 dx. Okay, and now this will be integral of 0 to 2 y of the first one. Okay, you can interchange, no problem. Okay, let's use this. Square root of 4x squared minus x squared over 4 squared divided by 2 dx. Okay, area total is 5.33 bar y. Your bar y here, okay, 5.33 bar y. Compute for this, the value. Integral of okay, maybe we can focus a little bit. Integral of, close open parenthesis, square root of 4 alpha x squared minus, close open parenthesis, fraction alpha x squared over 4, okay, squared. Why I have two parentheses? Only one. Is squared. I need to type 1/2. Integral of, then fraction, close open parenthesis, square root of 4 alpha x squared minus fraction alpha x squared over 4 squared divided by 2. Your limit is 0 to 4. The answer is 9.6, and so therefore bar y is 9.6 divided by 5.33. The answer is 1.8. Okay, so still our answer is letter A. Okay, so that's how to find the centroid of areas bounded by curve. Okay, let's have another example. Find the centroid of the area bounded by the curve y squared is equal to 4x, x equals 4, and x axis. Okay, so the first thing to do is to identify the curve. So this is a parabola that opens to the right. The center is 0, 0. X equals 4. Okay, x equals 4, and this is y, that is equal to the square root of 4x. Okay, so here and the x-axis. Okay, this is our x-axis. Here we only need for this area bounded in the first quadrant. Okay, it already satisfies the curve x equals 4 and the x-axis, not the 2, not the whole. Okay, if this should have been eliminated, x-axis, so we will consider the whole parabola. So here we will use either horizontal or vertical. Okay, let's say let's use y dx, and the centroid is here. This will be our bar y. Okay, bar y will be, we will use the concept for y over 2, and this is bar x. It will always be x. Okay, next, compute the area of the bounded region, first quadrant only. The point of intersection, this will be 4 and okay, if substitute 4 here in the first equation, that is 16. 4 times 4 is 16, square root of 4, square root of 16, that is 4. So y equals 16. Y equals 4. 4. Okay, the area, that will be integral of y dx. Okay, if this is dx, our limit will be in terms of x, 0 to 4. And your y is the y of the first one, square root of 4x minus y of the x-axis, 0. Okay, dx, integral of 0 to 4. So this is our area total. Integral of square root of 4 alpha x, 0 to 4. Let's just wait for the answer. This is our area total. Once we have the area total, okay, we will now compute for the value of the centroids. Area total bar x, that is equal to integral of x dA. Okay, integral of your limit 0 to 4. Okay, our answer is 10.66. Okay, 10.66. Okay, x times the value of the differential area. Okay, this is our dA, square root of 4x dx. Okay, limit from 0 to 4. Again, using calculator, integral of alpha x times square root of 4 alpha x, and limit 0 to 4. This is 25.6, and the area total is 10.66 bar x. Your bar x is 25.6 divided by 10.66, 2.4. Solving for the bar y, solving for the bar y, we have area total bar y, that is equal to integral of x1 x2, okay, x1 x2, and y over 2 dA. This can be replaced by y1 squared minus y2 squared divided by 2 dx. Okay, y of the curve, that is square root of 4x. Okay, and minus, that is squared, correct, and minus y of the x-axis, that is 0. Okay, dx divided by 2, and your limit is from 0 to 4. Okay, so calculating area total, this is 10.66 bar y. Let's compute for the value. Integral of fraction. Okay, fraction, square root of 4 alpha x squared divided by 2, limit from 0 to 4. That is 16. Okay, your bar y therefore is 16 divided by 10.66. The answer is 1.5. Okay, so our centroid, okay, so our centroid is bar y is 1.5 and bar x is 2.4. Now using the area of the common shapes, okay, if we are dealing only with parabola, ellipse, circle, we already have we can use that concept, area of the common shapes. For here, without using integration, this is your curve and this is the point of intersection 4 and 4, and this is 4, this is 0 0. Okay, so this is a parabola and this is half of parabola. Okay, what is the centroid? We have the formula that is 0.6, 0.6 of this. Okay, 0.6 of x. So our x, the value of x is equal to 4. Okay, from this point to that point, that is 4. So 0.6 from this point, that is 0.6. Your bar x, that is equal to 0.6 of 4. That is equal to 4 times 0.6, 2.4. Okay, 2.4. So check our bar x is still 2.4. Our bar y, okay, the location of the centroid from x-axis, that is 0.375 of y. Okay, this is your y. This from this point to that point, that is the value of y. Okay, that is your bar y. So bar y, that is 0.375 of this y is this coordinate. Okay, y of this, that is 4. So 0.375 times 4, this is 1.5. So when we are dealing with parabola, ellipse, circle, okay, spandrel of a parabola, okay, quarter circle, quarter ellipse, we will use this method easier than integration, okay, in finding the centroid. Okay, so thank you for watching. Please don't forget to subscribe if you are not yet subscribed, and click the bell notification also so that you will be updated when we have new videos. And later on we will complete the topics for integral, then we will move for the other subjects in mathematics. Okay, thank you.